Paint is a product that almost everyone uses, whether for walls, furniture, cars, or art, yet few people stop to think about how it is made. Making paint is a combination of chemistry, engineering, and artistry. It begins with understanding what paint really is. Paint is a mixture of pigments, binders, solvents, and additives. Each component plays a specific role. Pigments provide color, binders help the paint stick to surfaces, solvents make it easier to apply, and additives improve properties such as drying time, texture, and durability. Combining these ingredients in the right way creates a product that is visually appealing, long-lasting, and easy to use. The first step in paint production is selecting pigments. Pigments are finely ground particles that give paint its color and opacity. Some pigments are natural, such as clays and minerals, while others are synthetic, created in laboratories to produce brighter, more vibrant, or more stable colors. For example, titanium dioxide is a white pigment that is widely used because it reflects light very well and makes colors appear more vivid. Red pigments might be made from iron oxide, while blues and greens can be created using synthetic compounds. Pigments are carefully tested for consistency, light fastness, and resistance to fading. If the pigment quality varies, the final paint color could be inconsistent. Once the pigments are chosen, they are ground into a fine powder so that they mix evenly with the other ingredients. Next comes the binder, sometimes called the resin. The binder is what holds the pigment together and allows it to stick to surfaces. Different types of paint use different binders. For an example, acrylic paints use acrylic polymer as a binder, while oil paints use natural oils like linseed oil. Latex paints, which are popular for walls, use water-based polymers. The binder also affects the durability, flexibility, and finish of the paint. It is carefully blended with pigments to create a uniform mixture. The ratio of pigment to binder is important. Too much pigment can make the paint dry too quickly and crack, while too little pigment can make it look thin and watery. After pigments and binders are combined, the mixture is milled. Milling is a process where the paint is ground and blended thoroughly using large industrial machines called sand grinders or attriters. This step ensures that the pigment particles are evenly dispersed in the binder. If the particles are too large or clumped together, the paint could appear streaky or uneven. Milling also improves the smoothness and consistency of the paint, making it easier to apply. With brushes, rollers, or sprayers, solvents are then added to the mixture. Solvents are liquids that thin the paint so that it can be applied easily. Water is the main solvent in latex paints, while oils or special chemicals are used in oil-based paints. Solvents evaporate as the paint dries, leaving behind the pigment and binder on the surface. The choice of solvent affects the paint's drying time, consistency, and finish. Fast-drying solvents are used for some wall paints, while slower-drying solvents are preferred for oil paints to allow more time for blending colors. Once the paint mixture is properly blended, manufacturers add various additives to improve its properties. Additives can prevent mold growth, reduce foaming during application, improve gloss, control drying time, or increase durability. For example, anti-foaming agents ensure that bubbles do not form when paint is stirred or sprayed. UV stabilizers protect the paint from fading in sunlight. Thickeners or flow agents help the paint spread evenly without dripping. Even small amounts of additives can make a big difference in the performance and appearance of the final product. Color matching is another critical part of paint production. Paint companies often need to produce exact shades requested by customers. To achieve this, technicians use precise measurements in modern technology, including spectrophotometers, which analyze the color of a sample and calculate the exact combination of pigments needed. This ensures that when a customer buys sky blue or cherry red, the color is consistent across different batches. Once the paint has been mixed, milled, and additives are included, it moves on to quality control. Each batch of paint is tested for viscosity, color, opacity, drying time, adhesion, and durability. Workers apply test swatches to panels or other surfaces to check how the paint spreads, how it dries, and how it looks under different lighting conditions. Only when a batch passes these tests does it move on to packaging. Packaging is an important part of the process because it ensures that the paint stays fresh and is easy to use. Paint is poured into cans, buckets, or tubes, depending on the type and intended use. The containers are sealed tightly to prevent air or moisture from affecting the product. Labels are applied to provide information about the color, type of paint, coverage, area, drying time, and safety instructions. Automated machines help fill, seal, and label containers efficiently, ensuring that each unit meets strict quality standards. Paint factories are designed for efficiency, safety, and cleanliness. Because pigments and chemicals can be messy or hazardous, workers often wear protective clothing, and machines are designed to minimize spills and contamination. Ventilation systems are critical, especially for solvent-based paints, to ensure that fumes are safely removed from the workspace. Safety is a priority at every stage, from mixing and milling to packaging and storage. Drying and curing are key steps that determine how well paint will perform. Once applied to a surface, the paint must dry and form a solid, durable layer. Water-based paints dry as the water evaporates, while oil-based paints dry more slowly as the oils oxidize and harden. Some paints require heat or additional treatments to achieve maximum hardness and durability. This process ensures that the paint adheres well, resists peeling, and lasts for years. Different types of paint are made using variations of this basic process. For example, interior. Wall paint is designed to be easy to apply and washable, while exterior paint is formulated to resist weather, sunlight, and mildew. Specialty paints, such as metallic, textured, or chalkboard paints, include additional ingredients or pigments to create unique effects. Artists' paints, such as acrylics, oils, or watercolors, are formulated for precise control, color, vibrancy, and blending properties. Despite these variations, all paints share the same fundamental components: pigment, binder, solvent, and additives. The science of paint continues to evolve. Modern research focuses on making paints more environmentally friendly, durable, and versatile. Water-based paints have largely replaced oil-based paints for many applications because they produce fewer harmful fumes. New pigments and additives improve color stability, scratch resistance, and energy efficiency in buildings. Some paints even have special properties, such as reflecting heat, purifying the air, or being washable and antimicrobial. Paint is more than just a liquid to cover a surface. It is the result of precise chemistry, careful engineering, and quality control. Each can of paint represents a combination of raw materials that have been transformed through grinding, mixing, testing, and packaging into a product that meets both functional and aesthetic needs, from the choice of pigments to the final seal. On a container, every step is designed to create a consistent, high-quality product. Next time you pick up a brush or roller, it is worth considering the journey of that paint, from showy, mined minerals and chemical compounds to a smooth, colorful layer on a wall, piece of furniture or canvas. Paint is a remarkable example of science and art working together. It protects, beautifies, and transforms spaces while providing endless opportunities for creativity. The next time a wall shines with a fresh coat of color, remember that it is not just paint. It is a carefully crafted mixture created through skill, technology, and attention to detail. Even a simple can of paint tells a story of innovation and human ingenuity. The pigments, binders, solvents, and additives are selected, measured, and combined to create a product that looks good, lasts long, and is easy to apply. Industrial mixers, milling machines, and automated packaging lines ensure that paint can be produced in huge quantities without sacrificing quality. Quality control guarantees that each batch meets exact standards, while modern technology allows precise color matching and performance testing. In the end, paint is a perfect example of how science and creativity come together to enhance the world around us. Finally, the process of making paint combines art and science in every step, from the initial selection of pigments to the final coating on walls or canvases. Every stage is carefully monitored and tested. The precise combination of ingredients, along with modern machinery and quality control, ensures that paint looks beautiful, spreads evenly, and lasts for years. Whether used for home improvement, art projects, or industrial purposes, paint transforms surfaces and environments, making it one of the most important and versatile products in